Hi, my name is Kimmo Ulltjärn, now with a microphone. I'm an IT architect at Region Östergötland, and if there would be a prize for the most complicated email address, I would most certainly win it. Today I'm going to talk about taming feral systems with our digitalization platform. First, a few words about Region Östergötland. It's the fourth largest healthcare provider in Sweden. We serve about 463,000 inhabitants. We provide healthcare in 3 hospitals. One of them is a university hospital. That means a lot of research is going on there. We have about 40 health centers. We provide dental care, public transport, and regional development. So we actually own trains. Now, from an IT perspective, it's not rocket science, you might think. But oh wait, it's way more complex. And most people don't know this. But you'll soon find out. So let's start with this digitalization platform. Let's have a look at the starting point. Of course, a lot of strategies. So the first one is a political strategy, a new direction for healthcare, where we focus more on early efforts to prevent illness rather than cure. Of course, we'll continue to cure illness, and we'll move healthcare closer to citizens. So basically, out from the hospitals and healthcare centers to our homes. And then we have IT strategies that describe what to do and why. And they all talk about digitalization in various forms. And we have them on national level and local level. The last one here is the digitalization strategy of Region Östergötland. So the question is, how can IT do this? What capabilities are needed to implement those strategies? That's what we are going to talk about. And you might think that those strategies were produced in that order. And of course, you're utterly wrong, because it was, going back and forth a bit. So let's talk about the strategic IT capabilities in the digitalization platform. First of all, we provide everything using APIs. It's accessible via internet using modern technology. And the most important thing is that we rely on open established standards. And this is important. So not just any standards. They need to be open and established. In the platform, we have 4 main areas. The first one is security, authorization, authentication, digital signatures and all that stuff. The second one is integration, and we do that contract-based with loose coupling, of course. And the third one, which we are going to have a closer look at today, is about storage. Files, databases, structured data, and unstructured data. And last but not least, management, monitoring, management, and publishing APIs and handling the economy. And to be totally honest, management is maybe not our strong point. And the reason we are doing this is, of course, to cater for the needs of the core business, to be able to provide functions to them in a more easier and structured way. That's the only reason for this platform to exist, actually. Here is another picture of this platform, which is maybe a bit more messy and more close to the reality. We have our legacy, the technical infrastructure, and something called nationella tjänsteplattformen, which is a platform that we use to exchange healthcare data among healthcare providers in Sweden. And we have the core business and our citizens, and we use the platform to provide services to the core business and citizens, of course, through applications using APIs in the platform. Now, that would be all nice, but we also have a huge legacy, so it will be a mixed system landscape. In a speech earlier today, we heard a bit about bimodal IT, and something like Gartner has introduced, and we are kind of using that as well. So on a technical infrastructure level, we go for stability, cost efficiency, and backstage. And facing the core business and citizens, we want to be more agile, innovation stuff. And that would be mode 2. And we also split our responsibilities when it comes to requirements. So core business and citizens, they can provide functional requirements, and IT go for the quality requirements. And then in the middle, we have rules and policies that govern the utilization of the digitalization platform. So now, storage, standards, and APIs. Now the fun part starts. So files and databases, that's not very new. But structured healthcare data, that's pretty fancy, actually. Already during the first day, we heard about HL7 fire. It was mentioned during the first keynote. How many remember that? Yeah, one person. Great. Today, I would like to draw your attention to OpenHR. It has a slightly different take on this. It offers more interoperability. We sometimes call it intraoperability. That is done through common clinical data models. It also has an API model, and it focuses on input of structured data, and it also provides persistency. So with this open established standard, we have great possibilities for cooperation, both local, national, and international. And the good thing is that we empower healthcare professionals, because OpenHR kind of supports low-code, no-code applications. Healthcare professionals are no longer forced to turn to programmers when they need help. They can do stuff themselves. That's wonderful. Now, let's talk about feral systems. How many in here knows what a feral system is? Okay, the same person again. That's interesting. So, an analogy with animals. See a feral system as a cunning fox, as opposed to the traditional enterprise resource planning systems, which is an interesting animal that tries to do everything but doesn't really succeed in anything. So the feral systems, they exist in addition to the core systems, and they are often a result of internal development, and often the leading people there are clinicians, so not software engineers. And thus, they bypass decided architecture. And on the other hand, they solve real problems for the core business, so good and bad. And in a large hospital, and we have 3, there are hundreds of them. So the reflex from the IT department is, of course, to do away with them, but we can't because they are really useful. The advantages with feral systems is that they make daily life easier. There are lots of knowledge in them, and they are a good foundation for research and innovation, and it's business-driven development in its core. And development is pretty fast initially, but then technical debt kicks in, and integration debt as well, because we have information silos, and security risks, and legal risks as well. We'll hear more about the legal stuff later on. And finally, management risks. I mean, this is a typical scenario. At IT, you get information that, well, you know, my colleague has retired and he has left a few systems behind. Could you take care of them? What? So, to sum up, business can't live without them, and IT can't manage them or replace them. So it's a tricky situation. So what we want to do is to tame them. The goal is to keep the advantages, of course. You know, research today and clinical everyday life tomorrow, and remove the disadvantages. So we want to have short development cycles, you know, less code for storage, security, and integration. Do you remember what the common functionality for those things were? No one? In the digitalization platform. Exactly. And how do we do that? Well, stepwise, of course, and with marketing. And marketing in our case means that we inform about advantages with the platform, and we also provide education and support in informatics. So, finally, freedom. Freedom is key here. So basically we say, develop what you want, how you want. There is only one condition. You have to use the digitalization platform. That's a key requirement. Back in the days, how it was. In Sweden, digitalization within healthcare started early. We had a lot of ad hoc solutions, thus information silos with lots of integration depth, and that was pretty expensive and unmanageable. So we thought, let's do better. Let's have one core system, or at least a few, to rule them all. Rather monolithic thinking, classical ERP. And what happened? We got our new core system, and the old systems, they didn't go away. They remained. Because they were useful. So the new goal is not to do away with them, but to tame them. So we have this bad situation, and we want to move them to this better situation where they reside in an ecosystem, where they are connected and manageable. Basically, one at a time, we move them, and then we can actually do something that very seldom happens within IT, remove the old one. Okay, so last, a few examples. Production planning. This is not a typical feral system, to be honest, because this is something that some of our partners use, this production planning system from Guli. But what we have done is that we have provided an API that a Guli capacity web server can call to get production planning data, instead of them having to put vendor hardware and software on-prem in our infrastructure. And the advantage of this is also that we get a vendor-neutral solution, because other vendors for production planning could use the same API. And to be vendor-neutral is kind of important when you are in the public sector. This is this is a great example. It's most probably the best example. It's for the unit where they make pathology for breast cancer. It's a proof of concept we made there. It's part of a master thesis, and you can follow that link and read the thesis. It's really good. On the left-hand side here, you have OpenEHR archetypes. Those are the clinical data models. Those are maximum data sets, and they cover many use cases. And they are international. They are developed in international cooperation, and you translate them into the language that you want to use them in. And what you do then is that you gather what you want to utilize for a special use case, for a specific use case. So then you have an OpenEHR template that you utilize. And they are often national or even local, like in this case. And then to the right, you have this application. It's an OpenEHR and Snowbird CT pathology response that you can see here. And that is a fine example of business-driven development. And also, in the previous version of this, which is not OpenEHR, but the old version of the application, input was totally unstructured and utterly useless for AI applications. But as you can see here, you input structured data, and that's a huge improvement. And here you have research and healthcare in synergy. It's great. It's awesome. So we'll continue on this path. This is lo-fi prototype for an application that we are creating currently for the burn injury unit. There's no good EHR system for burn injury in Sweden, so we create our own that we will utilize, we and potentially also Uppsala. This is another cool thing, health data from Google Fit, a proof of concept. Traditionally, we've been able to provide data to our citizens, but the other way around has been a bit tougher situation. And this changed drastically because we proved with APOC, we created this web application that takes data from the Google Fit API and puts it in the OpenEHR storage in the digitalization platform, and then you can use it for whatever purposes you want. Well, not everything. Everything that you have agreed upon with the user. Anyways, the cool thing here is that we have the same design pattern when a citizen provides health data as when a patient provides healthcare data. And the thing is that in Sweden, we have different laws for those two cases. But from a technical standpoint, it's the same thing. And Region Östergötland provides backend. So we continue. We do the same thing with telehealth monitoring, which is under procurement. So we have the patient side here with measurements, forms, chats, messages, bookings and video, typical stuff with that. And they connect to the platform, store stuff in the OpenEHR storage. And on the other side, healthcare professionals use the electronic medical record to do monitoring, patient administration, communication, and they can create forms. And the good thing is that by doing like this, we can actually hook up patient equipment from other vendors. It's pretty cool. And we can add clinical decision support, AI and stuff from other vendors on the other side, on the healthcare side. And eventually, in a few years' time, possibly, maybe, we could also hook up the core system once the core system gets modern APIs. I can't predict that when that will happen, but anyway. So, to conclude, we are actually already reaping the benefits of APIs and common functions in the digitalization platform. And those common functions were about security, integration, storage, and management. And today we've spoken specifically about storage, where we have seen that open established standards matter because then you can cooperate internationally. And we use OpenEHR to store structured healthcare data. And that is something that reduces complexity because we get less code in our applications. They go towards low code, no code. And it empowers the healthcare professionals. They can do stuff without being dependent on software engineers. And that is maybe one of the best things. So it's not rocket science. It's way more complex. But it's our task to make things easier. Thank you.